Okay, so today we're going to look at the fractions past paper questions. So a big collection of past paper questions based on topic can be found on the National 5 Maths Applications website. So you're able to find all the past papers for a particular topic. So fractions, percentages, statistics, whatever. Okay, so it's a good place to go if you're looking for some topic specific questions to try. So what we're going to go through today is the fractions past paper questions. So question number 1, write the following values in order from greatest to least. 0.388, we've got 3 over 8 or 3/8, 38.38% and 0.39. Justify your answer. So that tells us we've got to actually do a bit of work and we can't just guess. And make sure you do show your work when we're doing these questions. So when I've got a mixture of fractions, decimals and percentages, what I'm going to look to do is get them all into the one form. Usually the easiest is decimals, so that's what I'm going to do. I'm going to convert to decimals. So I'm going to have to convert this fraction and this percentage. Okay, and I'll put that wee star up there. Right, so let's just start off with the easiest one, and that's probably the percentage. So I need to convert 38.38% into a decimal. To do that, you divide by 100. Remember, a percentage is always out of 100 as a fraction, so that's the same as dividing by 100. Move the decimal point 2 places to the left, so it's going to be 0.3838. Now I'm going to take a look at the fraction, 3 over 8. That just means 3 divided by 8. So I'm just going to set up a division sum where I'm doing 3 and dividing it by 8. How many 8s fit into 3? The answer is 0. I'm going to keep going. I've got 3 left over. I can fit 3 8s into 30. 3 times 8 is 24. So I'm left with 6. I can fit 7 8s into 60. That's 56. So I'm left with 4. And then how many 8s can I fit into 40? That's 5. So that's me put those into decimals. So now I can go from greatest to least, putting these in order. The biggest one is going to be 0.39. Then we're going to have 0.388. And then we're going to have 0.3838. Remember, when we're doing these, put it back into the form you found it in the question. Okay, so that was actually the percentage. And then after that, it's going to be 0.375. Just take a wee bit of time. I've maybe done that quite quickly. Just take a wee bit of time. Make sure that you go through, and those are indeed going down the way. Make sure you're looking at the place value particularly. Okay, so if I was comparing 0.39 and 0.388, I've got an 888 and then I've got a 9, but that doesn't mean that the 881 is higher, because if you actually look at place value, you've got a 9, and another one you've got an 8, so obviously the 9 term would be bigger. Alright, so just make sure you're careful with those. Next question. A basic cookie dough mix requires butter, sugar, flour and chocolate chips. A sixth of the mix is butter, a third of it's sugar, a quarter of it's chocolate chips, and then the rest is flour. Calculate the fraction of the mix that is flour. Quite a kind of classic fractions question here, where we are told the amount for some things and then there's a missing amount we've got to work out. First thing we need to do is how much has been used up by butter, sugar and chocolate chips. So what we're just going to do is add those fractions together, and then to find out the rest, okay, we're going to subtract from 1, because the total, when we're dealing with fractions, the total is always out of 1. First of all, let's add these fractions together. So I'm going to be doing this and adding all these together. Okay, now a couple of things that I can do when I'm adding fractions. I'm trying to add a sixth, a third and a quarter. What I'm looking for, okay, and I can either add all 3 numbers together or I can add them up at the one time. What I'm really looking for is the lowest common multiple of the denominators. So that's 6, 3 and 4. What's the lowest common multiple of those? That's the easiest way to do it. There are other methods. I could look and see if there's anything that I can do to a third, the 3 in the bottom. Is there anything I can do to that to turn it into a 6? And so on. Okay, you could also use the smile and cross method as well as a couple of ways that we could do it. Easiest way though, if you can spot the lowest common multiple, then you've got it straight away. So let's just think about the multiples 4, and I'm just going to put the multiples of 6, the multiples of 3, and the multiples of 4. Multiples is just times tables, right? So for 6 it would be 6, 12, 18. I won't go any further, just for now. For 3 it would be 3, 6, 9 and 12. And for 4 it would be 4, 8 and 12 and then so on. Hopefully you can spot out, and I'll just do that just now to show it obviously continuous. Hopefully you can see then the lowest common multiple, so what's the common one, is 12. Okay, no other ones match up, so that's what we can use as our denominator. Okay, so I'm actually adding a sixth plus a third plus a quarter. Okay, and now I can then turn those into fractions over 12. Like I say, this is one way to do it. There are a couple of other ways. You could just add the sixth and the third together. You could just add the third and the quarter together, whatever. Okay, so what I'm now thinking is, what have I done going from 6 to 12? Well, I've multiplied the 2, so I need to do the same to the top. So this will become 2. And you can see that 2 over 12 is obviously a sixth. What have I done going from 3 to 4? 3 to 12, sorry, I've times before, so I need to do the same to the top. And again, you can see that 4 over 12 is a third. And then lastly, what have I done to 4 to turn it into 12? I've multiplied by 3, so I need to do the same to the top. So it's going to be 3 over 12. Add these up. 2 plus 4 plus 3. 2 plus 4 is 6, plus 3 is 9, so it's going to be 9 over 12. And what I'd like to do is simplify that down. Hopefully you can spot that I can divide both top and bottom by 3, so it becomes 3 over 4. Okay, that's not me finished yet. What we're looking for is the fraction that's flour, and we're told that that's the amount that's left. Now the total for any fraction, right, is going to be 1. If you start off, if you think about it in percentages, the amount of mixture would be 100%. That as a fraction is just 1. So what you're always going to do is, to work out what's left, you're going to subtract from 1. Now hopefully it's quite easy to sometimes kind of spot this. If I've got 3/4, I've obviously got a quarter left. But in terms of taking it away from 1, what we can think about is, what is 1 as a fraction in terms of quarters? How many quarters is there in one whole? Well, there's 4. So now I've got matching denominators. 4 take away 1 is just a quarter. Okay, but just going back, a couple of ways you could have obviously done that. You can add 2 fractions at a time and then add the other one. You could use the smile and kiss method and so on, but when you try and find the lowest common multiple, that's going to help you. You won't have to then simplify, and you'll hopefully be dealing with numbers that are a bit less confusing. Okay, let's look at the next question. Guests at a wedding were asked to choose their main course. 3/7 of the guests chose chicken, 1/3 of the guests chose beef, and the remaining guests chose the vegetarian option. Calculate the fraction of guests that chose the vegetarian option. So again, I'm going to add up these two, and then I'm going to take away from 1, because it's one whole. Okay, that would be the total amount. To work out what fractions left, subtract from 1. So what I'm looking to do is 3 over 7 plus 1 over 3. Now what I want to do, just in this example, is show you the other kind of method that we could use. Right, now this isn't really this will work every time. However, if you can think about what the lowest common multiple is, that's usually better. Okay, sometimes when you do this method, you'll get the lowest common multiple. However, always try and look to do that first. So what I'm going to do is I'm going to multiply the two denominators together. Right, that will give me 21 in the bottom. So what we're thinking now is if I've multiplied these two numbers together, what must happen to the top? Well, on the left hand side, I've obviously multiplied 7 by 3, so I'd have to multiply the top by 3 as well. Likewise, on the right hand side, I've multiplied 3 by 7, so I'd also have to multiply the top by 7 as well. So that's kind of where we get that smile and cross from. So that's going to become, and I'll change my pen back, 21 on the bottom. 3 times 3 is 9, and we're adding on 7 times 1, which is just 7. 9 plus 7 is 16, so it's 16 over 21. But the lowest common multiple of 7 and 3 is also 21, so you would have got there if you were using the other method. Okay, so I've now got 16 out of 21. Nothing I can actually do to simplify that down. I'm looking to work out what's left, so let's go for veg option. Fraction. So the total amount of guests as a fraction, the total would be 1. Okay, that's the whole part. And what we're looking for is what's left once 16 out of 21 has been used up. Alright, so I'm always going to be taking away from 1 in this case. Hopefully you can see, right, you can just by looking at 16 over 21 that you've got 5 to go, okay, before you get up to 21 out of 21. So you can just see that. But you can also think about 1 in terms of how many 21s is that, or how many 21ths is that. Okay, so it would be 21 out of 21. Take away 16 out of 21. Our denominators match, so we just take away the top numbers. So 21 take away 16 is 5. So it's 5 over 21. Okay, for that one. But hopefully you can just see by looking at 16 over 21 that it becomes 5 over 21. Okay. Right, next question. Question 4. A class of pupils were asked about how they travelled to school on a particular day. A sixth of them were driven, 2/5 took the bus, and the rest walked to school. Okay, so calculate the fraction who walked to school. So exactly the same. I should say, by the way, that these are all non-calc ones, they're all on paper 1. I'm just going to add these up and then subtract from 1. Right, you'll get really used to doing these ones. So I'm needing to add a sixth plus 2/5. Okay, now you could find the lowest common multiple. Turns out the lowest common multiple for this is actually 30. That's one thing that we could do. So both of these will become over 30. Then I think to myself, what have I done to the 6 to turn it into 30? I've times by 5, so I'd have to do the same to the top. What have I done to the 5 to turn it into 30? I've times by 6, so I have to do the same to the top, so it becomes 12. But I could also use the smile and cross method as well. Okay, so adding those together, I'm going to get 17 out of 30. And then to find out what's left, so this is the fraction that walked. I'm going to subtract from 1, because that's the whole amount. 1 is obviously the whole part. So 1 take away 17 over 30. Again, hopefully you can see that to go from 17 up to 30, it's 13. So it would be 13 over 30. That's one way to look at it. But I can also turn 1 into in terms of over 30 and then do the subtraction. So that's going to be 13 over 30. And I'll just move down a wee bit. Okay, and that's our final answer. Those ones are always quite similar. Add the fractions you're given and subtract from 1. Just make sure you're reading the question in case it throws any different kind of bits in. Question number 5. Carol knows that she can travel 280 miles on a full tank of fuel. She's making a trip of 110 miles. The diagram below shows the fuel's gauge. Does she have enough fuel to make her journey? Okay, now our wee fuel gauge is split up nicely. So I can be able to work out what fraction of fuel she's got. Okay, left. I can work out what fraction she's got and take that fraction and work out the amount that she's got left from this value here. If she knows that a full tank's 280 miles, if we work out what fraction of fuel she's got left, we can work out how much the actual miles that she can travel. So let's take a look at the total number of segments I've got. I've got 1, 2, 3, 4, 5, 6, 7, 8, and I have gone 1, 2, 3. So she has 3/8 left. I'm then going to work out what 3/8 of 280 actually is. Again, this is non-calc. How do I do a fraction of an amount? Divide by the bottom times by the top. So 280 divided by 8. Okay, work that out. Okay, if you're struggling to do that, just make sure you set out a sum if that's what you need to do. So 280 divided by 8. Okay, that would actually be 35 if you can do that in your head. If not, just come to the side, do a wee division sum. 3, so 3 times 8 is 24, you've got 4 left, so that's where we get the 35 from, okay? And 35 times 3, if we want to do that on the side as well, 3 times 5 is 15, carry the 1, 3 times 3 is 9, so that's 105. So she can only travel 105 miles, her journey is actually 110 miles. Does she have enough fuel? So make sure that we just make a wee sentence. No, as she only has has 105 miles left, but 110 miles left to go. Okay, so tying in fractions, but we're also looking at reading a scale there as well. Final question, number 6. Dave and Elaine each have the same monthly data allowance on their mobile phone contract. Dave has used 4/7 of his monthly data allowance. Elaine has used 5/8 of her monthly data allowance. Who has used the most data? Give a reason for your answer. When I've got two fractions, I mean there's two things that I could do here. When I've got two fractions that have got different denominators, I can't really compare them directly. So what I can do is try and get them to have the same denominator. So what I'm looking for is the lowest common multiple between 7 and 8. And I could also use the smile and cross method if you like. I could do that as well. Okay, I can multiply the two denominators together and then do the same to the tops as well. Something else that I could do if you were really struggling is you could set out division sums. Okay, you could do 4 divided by 7, 5 divided by 8, and keep going until you get to a point where you're able to decide what one's the most. What I'm going to show you though is making the denominators the same. Okay, so there is a couple of options. Make sure you're comfortable with all of them, I guess. Okay, one thing you can just do is make the denominators to match. Okay, so I'm going to try and find the lowest common multiple of 7 and 8. Okay, if I just go through the times tables, multiples of 7, multiples of 8, 7, 14, 21, 28, 35, 42, 49, and then 56. 8 would be 8, 16, 24, 32, 40, 48, 56. So there's our lowest common multiple there. Right, might be able to tell straight away. So that's one way we can just work out what the lowest common multiple is, or we could use a kind of smile and cross method, multiply the denominators together, or turn them into decimals by doing a division. But I'm just going to do turn them into fractions over 56. So we're going from, we started off with 4 over 7 and 5 over 8, and we have gone to this. Okay, what have I done to 7 to turn it into 56? Well, I've times by 8, so I'd have to do the same to the top. So that's going to be 32. What have I done to 8 to turn it into 56? I've multiplied it by 7, so I'd have to do the same to the top. So it's 35. So this one here is the most data, and that is Elaine. 5 over 8 is more. Make sure you justify that. A wee there for statement. So Elaine used more as 4 over 7, 5 over 8, sorry, 5 over 8, which is, you can put this in as well, 35 over 56 is greater than, wee symbol, 4 over 7, which was 32 over 56. Make sure you're always writing a wee statement to justify your answers. So, good wee mix of fractions questions there. Hopefully you're feeling kind of comfortable with them. It'll be those kinds of questions that do come up. Just make sure you're comfortable with moving between fractions, decimals and percentages. You feel comfortable with adding, subtracting fractions, and you're also kind of comfortable with changing denominators, okay, and the different ways to do that. One thing I would say, make sure you can definitely do division sums involving decimal answers. So make sure that's something that you're keeping up with, because non-calculator is obviously 1/2 of your National 5 APPS exam, so make sure you're comfortable with non-calculator questions as well.